Hello and welcome to The Ways of Math. This is your host, Dan the Math Man. Today we're bringing you another video series, this time on this introduction to sets. Now this is just going to be an introduction. There's obviously much more stuff that we can do with sets. In fact, there's an entire branch of mathematics called set theory. We won't delve heavily into it, but the motivation is to get a basic introduction for what are sets, how they're used, what are the applications, and just to get a common familiarity. A lot of students will encounter this in an early maybe proofs course or a logic course or perhaps even like a college level mathematics course, some sort of discrete course. So this is part one. Okay, so in this video we're just going to have just kind of the beginning definition. So we're going to describe what is a set, kind of how it's used and that sort of thing. Also how we express sets. So there's different ways that we express sets. We're also going to talk about some elementary kind of beginning notations for some of the notations we use when we're discussing sets. And then also some of the commonly used sets. So there's some explicitly defined sets that we already have. So there's special symbols for these when we're talking about these. Okay, so let's begin. So the first thing we're doing when we're talking about sets is what is a set. Okay, so when we're talking about sets, a set is a collection of objects, right? And so in fact we have a precise mathematical definition. So we're going to have definition up here. Okay, this is our first mathematical definition. Okay, so a set is a collection of objects called elements, or sometimes they're also referred to as members. Okay, so the key thing to remember here is we're defining a set there, and in this set it contains these things called elements. Okay, sometimes they're also referenced as members. For the duration of this video we're going to be calling them or referencing the elements of a set. Okay, so these elements can be anything. They could be numbers, they could be words, they could be things like apples and oranges, fruits, vegetables, cars. I mean, anything you could think of that's any kind of object that you might want to categorize or group together into a set. The basic concept of a set is that we can include these things into some sort of grouping of some sort. Okay, that's essentially what a set is, and why this is so important is we'd like to be able to group things. Okay, so a set can be denoted in multiple different ways. Okay, so the different ways we can do this, so we can express a set. So ways to express a set. Okay, this can be done by description. Okay, which is essentially we just describe the set, right? So we could say it's a set of fruit, or it's a set of even numbers, or it's the set of four-door automobiles, things like that. So we can use description as a means of describing a set, and normally it's done either verbally or we can express it by writing it. Another way we can express sets is what's called roster form. And roster form is kind of an explicit way. So what we actually do with roster form is we explicitly list the elements of a set. And we use some special notation for this. So we use these curly braces, right? And these curly braces are used specifically to define a set. So things contained in here, so some sort of list contained between these two braces are the elements of a set. So when we're talking about roster form, we're going to have these braces used, and then we're going to have a list of something inside. So there could be a list of numbers. For example, we could have a list of numbers 1, 2. So the elements of this set are the elements 1 and the elements 2. Or perhaps we could have the list like apple, orange, right? So that could also be a set as well. And so this is called roster form. Another way we can describe a set, or we can express a set, is what's called set builder, or sometimes called set generator form. Okay? And so this has a slightly more formal way of expressing it. And this is great for sets where we might not be able to explicitly list the elements before there might be too many elements. There might be an infinite amount of elements in these sets. So we use set builder form to kind of give us a way of building the set or generating the set. Okay? And so this, again, is described by using these curly braces. Okay, so set builder form. We have these curly braces at the beginning and the end, okay, to denote that we're going to talk about elements within a set. And then we have these two sections, okay, so we define an element name in the first little part, okay, so this could be things like X or Y or usually some sort of variable, especially the way we use it in algebra and higher level mathematics. We might put this, and there could actually be multiple element names because there might be multiple types of elements that are included in a set. For example, we could have a set of ordered pairs, so they might have X's and Y's, things like that. And then there's this vertical bar. Sometimes you'll see a colon as well, just two dots. But this vertical bar is not just a separator, it actually means something. This vertical bar means such that. Okay, we can also think of it as subject to. So this is basically saying that in order to be included in the set, such an element that we describe here has to satisfy a certain condition. Okay, so for example, so we're going to have some sort of condition here as what it means to be included in the set. Okay, and so again, we describe an element name such that and some condition on the element in order to be included in the set. Okay, so let's see some examples of these. Okay, so let's take a look at a descriptive example. So for description, okay, we might just say the set of the days of the week. Okay, and that describes a set, right? The days of the week, of course, being Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So we can just describe the set, and that a lot of times is satisfactory. And then when we're in common speech and we're verbally describing a set, this is really a common way, a very convenient way of expressing it. Now we can also express the exact same set in roster form. Okay, so what would that look like? Well, we use the curly braces, okay, and then we list the elements. Well, what are the elements? They're the days of the week. So we could say Monday, Tuesday, right, Wednesday, and I'm going to run a little bit out of room here, but this continues with Thursday, Friday, Saturday, and of course Sunday. Okay, and then when we conclude the list of the set, we use this curly brace. Oops, that doesn't look very nice, does it? This curly brace to conclude the set. So this would be the roster form of the set. Okay, we can also describe this using the set builder notation, right? And so let's say we call our element D, right? So D is going to represent the elements of this set. Okay, these elements are going to be days. So we're going to say D is the element in this set such that D is a day of the week. Okay. So sometimes we can describe the condition for what it means to be included in the set verbally, or sometimes we might have something explicit like an inequality or some other type of description that can go in there. Okay. Now, a couple things on notation. Sometimes roster form, as we kind of see, sometimes it might be not infinite necessarily, but it might be really big to express, but there might be a pattern to the roster form. Okay, so sometimes we use these things called ellipses, okay, to kind of describe that it just simply means when we see these ellipses, that means continues on in the pattern of. Okay, so for example, kind of returning back to this roster form of the days of the week, I could have expressed it as Monday, Tuesday, right? I've already kind of established sequential days starting with Monday. And then I could put these little dot, dot, dot. These are my ellipses. So these are this thing here. These are called the ellipses. Okay? And it simply means continuing on in this same pattern established. And then I could just write Sunday. Okay? So then we would infer that we continue sequentially going through the order of days until we reach Sunday. So Monday, Tuesday. This implies Wednesday, Thursday, Friday, Saturday, and concluding with Sunday. Okay? So ellipses are a very nice tool for doing this. Now, sometimes if it's an infinite set, these ellipses might occur at the end. For example, suppose I wanted to describe even positive integers, right? I can do that using a roster form and ellipses, right? So I could do 2, 4, 6, and then dot, dot, dot. And this time I won't put a conclusion on here because there's infinite positive integers, right? I can continue going on 8, 10, 12, 14, all the way 104, 2,622, for example, okay, etc. And so this is implying that it is an infinite set, okay, but it still follows the same pattern. So we can use this. So these ellipses are rather convenient, okay? Another common notation that we have, which is really is when we're talking about the elements, whether an element is contained in a particular set. So for example, we use this symbol, this little E-looking symbol, okay? And this symbol is read is an element of. Okay? So on one side, we're going to end up putting an element here. So there's going to be an element here. And on the other side, we're going to put a set. Okay? And this could be the name of the set, or we could actually physically write the set out there. And so we were describing that this element is a set of, or this element is in the set. So it's an element of the set. So for example, Monday is an element of the set, the days of the week. Okay, oops. I want it to look like a number there. Okay, so Monday is an element of the days of the week, or I could write out the days of the week as well. Okay, so this, you'll see this symbol used a lot when we're talking about elements of sets. Or another example is, suppose I define A to be a set, right? So a lot of times we call sets by specific letters so we can reference them a little easier without having to write the set every time. So suppose I define a set A as being the elements 1, 2, 4, and 7. Oops. These curly braces take a little bit of practice to write. Okay, so A is this set, so we've defined it again in roster form. Okay, so then 2 is in fact an element of A. That's a true statement. 2 is in this set. However, the number 3 is not in this set. So if I wanted to describe an element that's not in a set, so if I have some object that's not an element of the set, for example 3, I would write this with a slash through it, and then this is read 3 is not an element of A, and we see that 3 is not in this set. Okay, now there's some very common sets that we reference throughout all of mathematics, okay, and they're usually written in this kind of funny bold notation. Okay, so we have this capital N. Okay, this denotes the set of natural numbers, what are called the natural numbers. Okay, now unfortunately the explicit description of the natural numbers changes from text to text and from mathematician to mathematician. Generally, the natural numbers consist of the set 0, 1, 2, 3, and we'll use these ellipses because it's an infinite set. Okay, so it's the set of all these non-negative whole numbers or non-negative integer numbers. Okay, sometimes you will see the natural numbers may not include 0, so be aware that in some texts, okay, and some classes, 0 is not an element of the natural numbers. So just be aware that sometimes that can pop up, okay? So when I talk about the natural numbers for the course of these set of videos, 0 will be considered a natural number, but just be aware that sometimes it's not considered a natural number for some texts. Okay, another common set is this bold Z, okay? Comes from the German word Zahlen, meaning number, and this is the set of integers. Okay, oop. Integers, okay? So this is, so we have ellipses on the front as well. -2, -1, 0, 1, 2, and then ellipses on the back. So this actually goes in both directions, right? So because the integers include all negative whole numbers, all positive whole numbers, and 0. Okay, so it has everything in it. So notice the usage of the ellipses on both sides to denote this continues on in this same pattern going negatively, so it implies -3, -4, -5, etc. And on this side it implies 3, 4, 5, etc. on that side. Okay. Another commonly used set is called Q, and this denotes the set of all rational numbers, okay? And we won't describe too much in detail the explicit definition of rational numbers, but loosely speaking, we can kind of think of rational numbers as the set of numbers that can be expressed by a fraction. So the set of numbers expressible in fraction form, okay? And that's what the set Q represents, okay? So anything like, even whole numbers are included in this, right? Because we can express whole numbers, right, as fractions over 1, right? So we can express the number 2, for example, as 2 over 1. That's a fraction, okay? That would also be a rational number. Or anything that's even not a whole number, like 1/2, 2/4, 317 over 411, all these things, even decimals, if they can be expressed as a fraction, like 0.333333, etc., is really just 1/3. That's also a rational number. Okay, another common set that we talk about is R. Okay, R is kind of the big set that we deal with most of the time throughout our algebra and calculus courses. Okay, and this denotes the set. So this is the set of all real numbers. Okay, so anything that's real, which means that anything that can be essentially, if measuring was possible for everything, this is the set of all things that can be measured. Okay, essentially it's kind of a way of looking at real numbers. Okay. There's also a special set that we deal with when we're dealing specifically with sets, and it's this kind of O with a slash through it, okay? And this denotes the empty set, okay? The empty set. So this is a set that contains no elements. And sometimes it's described this way when we're talking about the name of the set, but we can also write this like in roster form. You might see this in roster form as simply 2 braces with empty. There's nothing inside. There's no elements listed inside. So you might see the empty set described this way. You might also see the empty set described this way. Okay? Now, for the purposes of what we are going to do, a really necessary concept is this concept of the universal set. Okay? And this brings us to our next definition. Okay? So, another definition. We're going to have a lot of these throughout this course of this series, okay? So the universal set, okay, and we're going to underline that because that's what we're defining here. Okay, so the universal set, and this is commonly denoted, so commonly denoted with a capital U. Okay, put a little U with a tail there. Okay, and so the universal set, which is denoted this way, is the set of all elements in a specified context. So this is the set of all elements within a specified context. Okay, now this is critical because the universal set is not a specific set. It depends on the context. For example, if we're talking about the ages of people in a room, right? So suppose we have some number of people in the room, we want to know what their ages are. So the universal set for that context, would be the set of the ages of the people present, right? So we probably wouldn't see in the universal set numbers like 127. I mean, probably not very likely that we'll have someone in the room with the age of 127 years. But we also wouldn't see negative numbers, right? So the universal set changes. Now, of course, if our universal set is all positive and negative numbers, well, then we might have positive and negative numbers. So it depends on context in order to be definable, okay? So context is incredibly important when we're talking about a universal set. A lot of times we also predefine this in order to establish context. Okay? Alrighty, so that's going to wrap it up for this video on this introduction of sets. Be sure to check out the next video and all the rest of the video in these series as they pop up on my channel. Also, please be sure to subscribe to my channel and also comment and leave any suggestions that you have in the comments below. Again, thank you for watching. Have a wonderful math-filled day.